Hello everyone, myself Karthikesh, working as Assistant Professor in the Department of Information Technology at Hindustan College of Engineering and Technology. In this video, we are going to discuss about the topic ACID properties, which is a part of database management systems. So these are the contents we are going to discuss. ACID. The word ACID means atomicity, consistency, isolation, and durability. So these are the four properties that govern the proper execution of a transaction, which in turn take care of the proper maintenance of the database management system. First, we'll move on with the property atomicity. In atomicity, or in other words, atomicity states that either all operations of the transaction are properly reflected in the database or none of the operations are reflected in the database. Let us consider an example where, for example, we are going to transfer the amount of 50 from account A to account B. So the first step will be to read the value of A, decrease it by 50, write it back to database, then we'll be reading the value of B, we'll be crediting 50 to the account B such that so that the value B will be increased by 50 and we'll be writing it back to the database. Now for example, consider after step 3, that is after updating the value of A, the system has failed before crediting it back to B. Now the amount from A is debited but it is not credited to B. If the system fails at this point, it will be into inconsistent state because the amount from A is debited but it is not credited to B. Here what Atomicity says, that is, if the amount is debited from A, it should be credited into B. That is, the transaction should be completed fully, or else the debited amount from A should not be reflected back. Which means that both debit from A and credit to B should not happen, or debit from A and credit to B should happen, right? So this is what Atomicity states. Either all the operation should happen or none of the operation should happen. That is the requirement of atomicity. Then we'll move on with consistency. In consistency, it is seen that the execution of a transaction in isolation preserves the consistency of a database. A transaction when starting to execute must see the consistent state. Similarly, the transaction when it completes successfully, the database should be in consistent state. During transaction execution, the database may be temporarily inconsistent, but upon completion of the transaction, it should be moved into consistent state. Let us consider the same example where an amount is debited from A and it is credited to B. For example, before start of transaction, when you are going with the sum of amount of A and B, will be having an amount. For example, A has 500 and B has 1000. So sum of A and B will be 1500. After debiting from A and crediting it to B, after successful completion of transaction, again when we go with sum of A and B, we'll be getting again 1500, but it will not be same during the intermediate state. So on successful completion, your database should be in consistent state. That is what the property consistency means. Next, we'll move on with isolation. So there may be multiple transactions that may be running concurrently. So when multiple transactions are running concurrently, each transaction must be unaware of other concurrently executing transaction. Because if it is aware of concurrently executing transaction, it may produce inconsistent result. So intermediate transaction result must be hidden from the other concurrently executed transaction. Let us see an example here. Assume that we have two transactions T1 and T2. Again, T1 is debiting an amount from account A and it is crediting the amount to account B. For example, after debiting the amount, another transaction T2 is trying to read the value of A and B. Now it is already debited, but it is not still credited to B. When we make sum of A and B, definitely it will be an inconsistent result. So the intermediate result of T1 should not be known to T2. This is what the isolation requirement is. Next, we move on with durability. Durability property states that after a transaction completes successfully, the changes done by the transaction should persist in the database, even if there are system failures. Once the data that is successfully committed should be available in the database. Even if there is system failure, it should be available. Let us consider the transaction again. An amount of 50 is debited from A and it is credited to B. Once the user has notified that the amount is successfully credited to B, the amount should be reflected both in A and B and it should be saved into the database for further usage. This is what about acid properties. So A deals with atomicity, C deals with consistency, I deals with isolation, and D refers to durability. Thank you.